In our last lesson, we mastered conditional statements, teaching our Python programs to make decisions, like a traffic controller directing vehicles. Now, imagine if that traffic controller had to manually direct every single car one by one through the same intersection multiple times. Inefficient, right? Today, we're going to give our programs the power to automate those repetitive actions, making them incredibly efficient. We're diving into the world of loops. At its core, a loop is a programming construct that allows you to execute a block of code repeatedly. Instead of writing the same lines of code over and over again, you tell Python, hey, run this section of code for me, not just once, but many times. This simple concept is profoundly powerful. It's how programs can process huge lists of data, respond to user input continuously, or perform calculations until a specific goal is met. Think of it like teaching your program to perform a chore automatically, freeing you up for more complex tasks. It's truly essential for any robust application you'll build. So why should you, a busy tech professional, deeply care about loops? Beyond just repeating code, loops are the bedrock of systems that handle scale and continuous interaction. Imagine you're building a system to analyze millions of customer reviews. Without loops, you'd be manually copying and pasting code for each review, which is obviously impossible and error-prone. Loops allow you to process every single review, one after another, with a single elegant block of code. They are critical for automating almost any routine operation. Think about scanning through log files for errors, updating thousands of records in a database, or even just sending out personalized emails to a mailing list. All these tasks, which would be tedious and time-consuming to do manually, become trivial with the power of loops. Furthermore, loops enable your applications to be interactive and responsive. Whether it's a game waiting for user input, a server continually listening for requests, or a monitoring tool checking system status every few seconds, loops are the engine behind that continuous interaction. They transform static scripts into dynamic, living applications. To truly grasp the essence of loops, let's use a simple analogy: baking a cake. Think of it like following a recipe. When a recipe tells you to stir the ingredients for 5 minutes, you know exactly how many times or for how long you need to perform that action. You stir, you check the timer, you stir again until the 5 minutes are up. This is very much like a for loop. You're performing a task for a definite number of times or over a known sequence, like stirring through all the batter. Now consider another instruction. Add eggs one by one until all eggs are incorporated into the batter. Here, you don't know the exact number of eggs initially or how long it will take. You add an egg, check if there are more, and if there are, you add another. You continue this action as long as the condition "eggs are left" is true. This is the essence of a while loop. You repeat an action based on a condition being met or not met rather than a fixed count. These two types of loops cover almost every repetitive task you'll encounter. Let's dive deeper into the for loop, our stirring for 5 minutes equivalent. In Python, for loops are your go-to when you need to iterate over a sequence of items. This could be every character in a string, every number in a given range, or most commonly, every element in a list or other collection. The power here is that the loop automatically handles moving from one item to the next. You don't need to manually keep track of an index or count. You simply tell Python, for each item in this collection, do this specific task. This makes your code incredibly clean, readable, and less prone to errors compared to manual iteration. For example, if you have a list of user feedback items, a for loop can easily print each one, process it, or store it, ensuring that every single piece of feedback gets the attention it needs without you writing redundant code. It's like having a robotic arm that perfectly processes each item on an assembly line, one after the other until the line is empty. Now let's explore the while loop, our add eggs until none are left scenario. A while loop is fundamentally different from a for loop because it doesn't care about collections or fixed counts. Instead, it's driven purely by a condition. The loop will continue to execute its code block as long as a specified condition remains true. This makes while loops incredibly useful for situations where you don't know in advance how many times you'll need to repeat an action. Think about asking a user for a password repeatedly until they enter the correct one, or a game loop that continues while the player is still alive. However, this power comes with a responsibility. You must ensure that the condition eventually becomes